Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at modular arithmetic. So this comes about when we consider just the remainder left over by division. So in computer languages, they often use this symbol to mean just that. 20% 9 means what is the remainder when 20 is divided by 9? And that is, of course, 2. 20 divided by 9 leaves a remainder of 2. Another way to write this is 20 is equivalent to 2 mod 9. That actually means exactly the same thing, that when 20 is divided by 9, there is a remainder of 2. So it turns out that there are 9 numbers modulo 9. It's a set of 9 numbers that we call Z9. And that's because every single integer is equivalent to one and only one of these numbers, modulo 9. If you take an integer and divide it by 9, you can have a remainder of 0, 1, 2, all the way up to 8. So 73, for example, would be equivalent to 1 mod 9, because when you divide 73 by 9, the remainder is 1. 34 would be equivalent to 7 mod 9. 5 is equivalent to 5 mod 9. So every integer is equivalent to one and only one of these integers mod 9. So this here is a set. And as I said, every integer is equivalent to one and only one member of this set. So just note, if a number is equivalent to 0 mod 9, that means when you divide it by 9, there's a remainder 0. It means that it is a multiple of 9. So the numbers 9, 18, 27, 36, 45, all of them would be equivalent to 0 mod 9. So what we're going to do is look at arithmetic between these numbers modulo 9, and we'll see if there are some interesting facts and so on. So for example, if we look at numbers in this set, if we were to add, say, 3 and 6, we would actually get 0 mod 9. So why is that? Because 3 plus 6 is 9, and 9 is equivalent to 0 mod 9. Turns out when you're adding, subtracting, multiplying numbers modulo n, whether it's modulo 9, modulo 8, whatever, it doesn't matter whether you add them first, then reduce modulo 9, or you do the opposite. You reduce them first and then add them. So in modulo 9, 3 times 6, well, that's 18, and 18 is also equivalent to 0 mod 9. So we sometimes get some weird things happening in modulo 9. Here, we've multiplied two numbers that are not 0 and somehow got an answer of 0. That can sometimes happen with the integers modulo 9. We're going to look at their structure. We're going to look at heaps of things about them in subsequent lessons. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.